Hello and welcome to this Info Security Magazine webinar. It's Michael Hill here. I'm the editor of the magazine and I'm delighted to be moderating this session, which is exploring security myth busting, dismantling the top 5 API myths. And a big thank you goes out to Salt Security for their sponsorship of this webinar today. So just before I introduce our panel, I'm just going to run through some of the housekeeping points my end quickly first. There's going to be 3 poll questions in the webinar today, so I'll read those out for you and announce when they're live. There's no right or wrong answer for those, but we're just very keen to get your thoughts and your insights, so please do take part in those, and we'll be having a look at the results of those before we finish up. You can also submit any questions that you might have for any of our speakers relating to our topic using your Submit a Question button. And again, we'll do our very best to answer all of your questions before we finish up in the session. For those of you on social media, our hashtag is InfoSecWebinar, so please do feel free to join in the discussion on social media as well. Just a quick note about CPE credits. This webinar does qualify viewers to 1 credit based on an attendance time of 50 minutes. That's 50 minutes. Once you've done that, you'll be able to access a certificate which you can submit for your credit. Please note it takes 48 hours for those certificates to be made ready for you to access and download. Okay, so to introduce our panel of speakers that we have joining us for this webinar. First, we have Michael Ispitsky, who is Technical Evangelist at Salt Security. Second, we have Michael Farnham, CTO at Set Solutions, and also Curtis Simpson, who is CISO at Armis. So a fantastic panel joining us for this webinar today. Just to quickly run over the outline of how we're going to structure the session. Will be an opening presentation from Michael Ispitsky first, very much setting the scene of our topic, and that will be followed by a panel discussion with all 3 speakers. So very much looking forward to the content that we've got lined up for you. So just before I hand over to Michael for his presentation, I'm going to open the voting on the first poll question, which is on your screen now. What we want to know is, does your organization use an API gateway? Is that A, yes, B, no, but we are working on one, C, no, or D, unsure? So we're going to open the voting on that one now, so please do vote on that. I'm very keen to get your thoughts on that question. But without further ado, I'll move on now to our presentation and hand over to Michael. So Michael, over to you.
Awesome, thank you, Michael. Hello, everybody. I'm Mike Ispitsky. Really quickly, because we have a few slides we're going to go through, and then we're going to quickly get to panel discussion. So very quickly, I am Mike Ispitsky. I am a technical evangelist with Salt Security. I'm also a former Gartner analyst covering application security, and also a security practitioner. I spent many years kind of architecting systems and also testing them and breaking them and helping defend them. So today we're gonna talk about API myths, specifically the top 5 we see most commonly, and they are very prominent. So if you are in this business of creating APIs, or maybe you're embracing cloud, this is kind of intertwined. We see this very frequently where organizations start to shift out of the data center. They start adopting cloud technologies. Ultimately, you're getting APIs as part of that. Some other factors that really drive API growth, maybe it does feel like a car crashing through a wall for many of us. But cloud native design, right? That's kind of containerization and APIs. I talked about data center consolidations. DevOps practices are also a big driving force for this. Expanding digital supply chain. We've been hearing a lot about this very recently. There's been quite a few incidents that I will not go into. We don't have enough time, unfortunately. But that supply chain is massive, right? There's a lot of partners and suppliers you're working with. They're building software. A lot of times they're building their own APIs. That's how we connect functionality and data. There's many other reasons, right, for adopting cloud, certainly availability and resiliency. The other big development trend is microservices architecture. We're going to talk a little bit about microservices in a bit. But yeah, all these things really driving API growth. So what's our first myth? Zero trust, right? We hear a lot of this. It can be a little bit buzzwordy, right? It's certainly an IT trend. There's a few, it's a principle, right? There's a few technologies that map to it. You might include software-defined perimeter there, micro-segmentation, zero trust network access. But ultimately, it's kind of a belief that we're going to enforce our traditional network access controls, but they need to be much more dynamic, right? Because our compute is very ephemeral and things are changing. There's a lot of API connections. And it also needs to be conditional, right? We kind of need to monitor that connection, what's going on within it, what is the user doing, what is the machine doing, and then we might adjust our network connections as a result. So why doesn't zero trust really help with API security? It's kind of an evolution of some very traditional network security thinking. If you take it to an extreme, there's kind of this philosophy of we have a castle, we have to fortify it, we have to protect it. And you kind of get into these discussions about defense in depth. The reality is it just doesn't work, right? The way we build APIs is that, particularly for internet-facing or public APIs, or maybe you're in the business of creating open APIs, like in financial sector, for instance, we need connectivity, right? We need people consuming APIs. So blocking access is kind of a non-starter. We see this commonly. Attacks occur in trusted channels and authenticated sessions. APIs, it's really not just a universe of user consumption, it's also machine identities consuming things. And you can't prompt a machine for authentication. The other problem is, a lot of the metadata you would need to inform these access controls is lacking. This can get into kind of development process and how you're building and releasing APIs, but API documentation, usually we see that this is very lacking. You need those things to really inform access controls. So it's really hard for a lot of organizations to microsegment things as much as they might like to, provided you're talking about specifically machine communication. But yeah, it's not going to solve API security. Very quickly, second myth, cloud service providers are protecting your APIs. This is kind of a spin, I'd say, on the shared responsibility model, and this can change, depending on what flavor of cloud you're consuming, whether it's infrastructure as a service, software as a service, or platform as a service. But cloud providers are in the business of selling you infrastructure services and compute. Application security, if they're providing it, or data security, are kind of secondary. API security is very light, if anything. It's just not their business model. You'll see kind of a reference architecture here for a sanctioned private cloud or a VPC or a VNet. I apologize if it's a little small for you, but this is kind of how enterprise architectures tend to look, right? It's kind of, you have some form of a perimeter. You might have multiple proxies and gateways that traffic flow through. And then within that, there's multiple APIs. It's pretty well-defined architecture. The problem is, the way most teams build applications is that things are very distributed. You might be calling out to APIs and other cloud services. You might not control them. App teams might be spinning up cloud compute that you're not even aware of, right? And maybe it's not even in the documentation, but you would see these things if you looked at the application and runtime. But Kubernetes, many of you might be adopting that. Kubernetes it's a beast to stand up. So there's a lot of appeal in going to a cloud provider to spin up a Kubernetes service, right? They abstract some of that complexity from you. Unfortunately, for security teams, that can be a big blind spot. You also have things like AWS Lambda functions or Azure functions. These may not even have infrastructure components. How do you employ traditional mechanisms like an API gateway? The code is going to run and terminate. And then we also have unsanctioned platform as a service. That could be a low-code platform like Salesforce, for instance. So there's a lot of different flavors of cloud, and securing it is much more about securing infrastructure and much less applications and APIs. So they have limited or no mature API security capabilities at the app layer, and certainly not across clouds, right? They're not going to sell you services that work in somebody else's cloud. It's very easy and cheap to procure cloud compute, right? I can spin up a cloud service very easily in Amazon if I just give them a credit card. I'll have it in a few minutes. And these unsanctioned cloud services really add to the problem of exposed and underprotected APIs. This kind of feeds into that issue of not having a good API inventory. Myth number 3, identity and access management, API gateways, and WAFs are not enough. For the sake of time, I'm not going to kind of explain these. I would hope everybody's kind of familiar with them. They're kind of principles in a lot of how we architect applications and systems. WAFs are very commonly employed to protect organizations from app layer attacks. Why don't these things work for API security? Well, they rely on proxy. And when you're in the business of designing APIs and connecting APIs, proxies slow down communication. It can create a lot of availability problems. The other problem, particularly with API gateways and WAFs, is they are dependent on signatures and rules for attack detection. And a lot of API attacks don't follow well-defined patterns. Particularly, they are not effective at catching business logic attacks and API abuse. API gateways are often paired with API management. The API management pieces themselves are often vulnerable, and attackers will exploit them. The other that I really like to point out, because there is kind of it's a very heavy focus on authentication and authorization with identity and access management. And yes, you should focus on it, but the problem is attackers will target authentication and authorization. So they will seek out your API keys. They will attempt to hijack authenticated sessions and user credentials. If you're embedding things in your mobile binary code, it's very easy for an attacker to extract those things. So relying on like an API key for authentication is not going to be API security. Myth number 4, workload protection secures APIs. I used to hear a lot about this. And again, for the sake of time, I can't really go too deep on this, but very quickly, workload is kind of that combination of the application and the compute it runs on. There's a very big focus in industry on solutions like cloud workload protection or cloud native application protection. Most of these tools focus much more on the container or their virtual machine and the configuration of it, and maybe the software you put into it. So it might do a form of vulnerability scanning or dependency checking. But they're very concerned with kind of limiting blast radius, right? If somebody compromises that container or the code that runs in it, they might pivot and attack other systems in the network. So they have value. They're going to protect some element of your system, but they really lack that deep API insight. And you really can't form this picture of what APIs are doing from the workload position in a network. And myth number 5, I'm going to wrap this one up quickly. This is an old favorite of mine, but developers will build in API security, right? We've, as a security industry, I feel like we've pushed the shift left mantra too far. It's kind of become extremist. There's a lot of value in introducing security concepts earlier into the development lifecycle, right? You don't want to catch things after production release. You want to try to catch as much as possible prior to deployment. But we've also gone too far, right? We've pushed a lot of security responsibility onto developers. We've given them tools that aren't built for a developer mindset or workflow, right? They should be focused on creating code, not trying to secure the code. They're trying to build functionality to satisfy the business, not secure things, right? Everybody's time is at a minimum these days. The other reality with shift left is a lot of the things that you can audit for in code or as part of design, they are not going to include business logic checks, right? And if you talk about secure design reviews or threat modeling exercises, they're very time consuming. It requires a lot of subject matter expertise. And you're still not going to really grasp all of this interconnectedness of APIs. So business logic attacks fly under the radar. It's not something that most scanners are built for, nor can they find it, right? They're just not architected for that, and they don't follow well-defined patterns. And this kind of gets into also the uniqueness of how every organization and developer builds APIs. If you start looking at REST APIs, it's a style, not a standard. Right, so how one person builds an API is going to look drastically different from another. So API security strategies, wrapping this up. Again, this is very quick kind of summary of the top 5 myths. I'd certainly encourage you to kind of look at some of the other material we're doing on this front, but API security strategies will incorporate shift left and that early secure design process and security testing and build pipelines. But they also stress fast detection and response. I believe that's it for the slides, Michael. So,
thank you so much, Michael. We thoroughly enjoyed that. A great presentation there. Some great points made that we'll no doubt touch on in a bit more detail in just a few minutes. Just a reminder that the first poll question is now live. There was a slight delay with that one going out. I must apologise for that. There was a slight tech issue this end, but that's been resolved now. So please do vote on that. And what I'm going to do is I'm going to leave that first poll question open for a few minutes longer than usual to make sure that you can get your votes in. So now I'm going to bring our slides down to reveal our full panel of speakers. So hello everyone, good to see you and great to have you here with us. So a fantastic presentation there from what we call Michael I for the purpose of this this session. So what I'll ask quickly that for our extra speakers to do is to quickly introduce themselves and share a bit of background as to the work that they do before we then kick on with the discussion. So Michael F, should we come to you first?
Sounds fine. Thank you very much, Michael I, and for that presentation. Appreciate that. So Michael Farnham, CTO with Set Solutions. We're a Houston-based cybersecurity reseller and integrator, and I've been in the industry in either IT or cybersecurity for about 27 years, started in 1994. Have about 4 to 5 years of pure AppSec experience in my background as well. So I've done a lot in this space, and it's kind of a passion of mine trying to get the industry to shift left and to envelop and engage with developers and that kind of thing to get security. So I'm very excited to be here. Thank you, Michael.
Fantastic. Great to have you, Michael. And Curtis, a few words from you.
You bet. Thank you. So I'm Curtis Simpson. I'm the CISO at Armis. Been with Armis now for almost 2 years. Prior to joining Armis as CISO, I was global CISO at Cisco Foods. I've spent about 20 years on the enterprise side of the house. Started out as a practitioner, built my way up based upon my technologist experience, gained that managerial experience, and have risen up through those managerial ranks since on the enterprise side of the house. I'm at Armis now because it was time to do more for everyone versus doing more for one company. So very much happy to be here and part of the conversation today. Fantastic.
Well, great to have you here with us. So we had a great presentation there from Michael I, and some really great points made. But I'm keen to get some thoughts from you too as well. So Curtis, let's come to you first. I mean, if you had to define what you see as the greatest API security challenges impacting organizations at the moment, what would you say they are?
Well, interestingly enough, I often talk about APIs specifically in relation to digital transformation. And I think post-pandemic in particular, we can all, or it resonates with all of us, that digital transformations are being doubled down on. There's a refocus on what really matters as part of that transformation. But again, DT equals API. And what we're rapidly running up against are a number of different challenges in relation to that. We're building APIs at scale without understanding what we're building at scale. Right? So the visibility into those APIs, but not just that they exist, but what they're doing, what's being exposed through those APIs. And we're moving so quickly now that we've almost jumped the shark because we've gone from a place of near zero visibility with a limited number of APIs to a massive number of APIs with still limited visibility. We've mostly focused on cataloging and authenticating APIs over the years, which I think most of us know hasn't really gotten us very far in terms of managing risk. So now what we're facing is that massive amount of new digital ecosystem that we don't understand, and we don't know whether it's being exploited, how it can be exploited, how it's potentially disrupting our compliance obligations, et cetera. It's pretty significant in terms of what we've been building in a short period of time.
Great, thanks, Curtis. Some great points made there. And Michael F, just quickly, a few thoughts from you and what you see as the main challenges impacting organizations.
I agree a lot with Curtis. The digital transformation issue, as I see internally, since people have focused on building, or starting to focus, or have been doing it for a few years, so focusing on building apps and microservices. The proliferation of APIs being the main way that communication is performed between those microservices has caused that trend of proliferation and just kind of the sprawl of APIs. And even if those aren't focused onto the website, if they're just internal apps, I was talking to a customer about it yesterday. They didn't realize just how big the problem is. And what they quickly find out is when they're trying to secure them, they don't have a good inventory, which Curtis brought up as one of those things they're trying to do, but they realize really quickly that they're still in a bad place to even finding out what they have. And then the next one is just, how do I take on this challenge of locking all of these APIs down when I've gone full bore into building out my environment with microservices? And it just becomes a daunting challenge very quickly.
Yeah, really interesting points. Thanks, Michael. And Michael, let's come back to you. Looking at the angle of how APIs can be targeted by attackers, and maybe you can share some insight and examples of the different ways that they can actually be targeted in attacks.
Yeah, absolutely. So quite a few. I'd say one kind of starts. Most attacker methodologies start with some form of reconnaissance. Old days, maybe they launched Nmap scan against target IP address space, and they scan things, try to throttle that down, be very stealthy. These days, a lot of that information is it's already kind of cataloged. You have services like Shodan or Project Sonar, so you can use some of that information to kind of find some exposed APIs and start your attacks from there. The other really common technique is taking client-side code, right? So if I hit a website, I'm going to take a look at that JavaScript, see what are the APIs I might be calling within code. The other is your mobile applications, right? A lot of the ways we consume functionality and data these days is on our mobile devices, right? So a lot of organizations are building mobile apps. Those front ends, they talk to back-end APIs. So attackers will reverse engineer the code, figure out what is the sequence of events to talk to APIs. The other, tried and true technique, some attendees might be familiar with this, but there's a lot of intercepting proxies like Burp Suite or Charles Proxy if you're a Mac user. There's OWASP Z-Attack Proxy. These tools are really good at exposing, what are all those client server communications, what's the web traffic, what are the API calls. So I'd say those are kind of the bigger techniques that attackers will start with and then kind of pivot from there.
Okay, fantastic. Thanks, Michael. And we'll touch on some of those points in a bit more detail very shortly. I want to open the voting on poll question number 2 now. So I'm going to quickly just bring that up on your screen for you. So we want to know next, where does API security rate on your company's priority list? And you can see your options on the screen there. A, high priority, B, medium, C, low, D, not even on our list, or E, unsure. So I'm going to kick off the voting on that one now. So that one is live. So please do vote on that one. I'm very keen to get your insight on that, and we'll come back to that in a few minutes' time. Let's just drop our slides back down now. And Michael F., let's come to you on another point here, which is looking at why are existing security tools often not enough to protect APIs now in the modern world?
I would say the biggest one is a lot of traditional, I guess one of the most common tools that's used in protecting applications in general, web applications, is a web application firewall. Those tend to be very, for one, very signature focused. So they have to find something that they know that is an existing issue, an existing vulnerability, and match that to a signature and try to stop that. And when you've got an API, which up until just the past few years really didn't have much of a standard, then it's really hard to find out based on what's coming across that it's a technique, if it's an attack or not. It just wasn't easy to understand. 2, there's there's just very limited visibility into the APIs from a WAF standpoint, because it's all about the network. If you don't have knowledge of how the API is built, then it's really difficult to determine if something is an attack or not. How do you differentiate when you don't know how the API is documented? And that, for that matter, that's also an issue with standard web applications with WAFs, if you don't have knowledge of the application. So that's why you have a proliferation of other technologies like IAST and that kind of stuff to inform you. And then when you have technologies like API security specifically, so you can bring in that documentation and know what's happening in that application or in that API. It's just things WAFs can't do.
Okay, that's really interesting. So Curtis, would you say then that with regards to the existing tools and their effectiveness at securing APIs. Do you think that the repercussions of the pandemic over the last year or so have kind of brought that to light even more, or do you think this was an issue that was the case anyway? It's just that it's been, like I say, been under the spotlight a bit.
It was an issue already. I think anyone who's been dabbling in this space and building APIs and attempting to apply responsible security measures to those APIs has quickly realized exactly what Michael said, in that we've got logic-based challenges. These solutions, these previous solutions do not help us with logic-based challenges. And yeah, do I think the post-pandemic, I think digital transformations in general have highlighted this need. But what's really continuing to highlight the need is the post-pandemic acceleration of those digital transformations. And I can give you even an example from our organization. So as the pandemic hit, we had a number of different integrations on our roadmap that were value-add integrations for our customers, but were somewhat deprioritized because many of those value-add use cases revolved around integrations of capabilities they already had in their stack to understand devices that had gone away from the office. But because many didn't understand all of the devices in their offices and they were working from those offices, being all the connected devices like IoT and OT within those facilities, they were focused on that because they were all working from those offices. Their critical business operations were being driven by those devices, etc. Well, when everyone went home, everything changed. Those use cases were still important, but now understanding those devices as they went remote became far more important. So what did that mean for us? That meant we had to build hundreds of APIs within a period of months. So when you look at where you were before to where you are now as a result of those types of pivots as you're reacting to these world events, you quickly realize that a problem that you had before is growing at scale that you've never encountered previously. So now where you thought something was interesting in the past, it's now become mandatory or critical.
Okay, thanks, Curtis. And Michael, on that point of existing tools, obviously it was something you mentioned in your presentation there. Anything you want to add in terms of kind of why the current issues of why they're just not effective anymore, and what should organizations be doing? I've been looking at things like zero trust and microsegmentation. Is that where these other approaches can kind of come in and be more effective?
Yeah, it's so I would definitely echo what Michael F said, that WAFs very dependent on static rules. I mean, they're essentially message inspection and message filtering. If you're paying for commercial WAF, hopefully you're getting some managed rule sets with that, and the vendor's kind of responding in a timely manner. If you came from the world of endpoint protection, or if you've ever worked with those solutions, you're kind of buying into this ecosystem that you hope the vendor is going to write a rule quickly enough. When there's a 0 day, they're going to get something in place in a few hours. The problem is, WAFs, they look for exploitable conditions, right? And this is going to go to the point Curtis was saying about business logic. It's very hard for a WAF vendor to write a specific rule set for your custom APIs and business logic. They're just not going to understand what that looks like. So most WAFs kind of, it's not lowest common denominator, but they go for kind of those big commercial packages, right? So maybe you're operating WordPress or SharePoint, right? So big web applications, a lot of organizations use, deploy those rule sets for certain types of exploits, like an injection attack. They might look for some very basic malicious characters, but attackers know this, and they know that WAF rule sets can be very basic. There's a lot of well-documented WAF evasions to kind of encode character sets to evade, WAF detection. So it's kind of a design flaw of WAFs. They just can't. They don't understand the context, right? And they're looking at that one transaction. They're not looking at sequences of transactions over time. That's how you kind of ascertain the context of what somebody's doing or how they're consuming your APIs. And to your other question, Michael, about microsegmentation, it's a valuable control, right? Like we talked about how organizations are moving to cloud. They're moving out of their data centers. Data centers gave you, a level of comfort, right? It was you owned the data center, you control that perimeter. You could, put in place firewalls as needed, stand up VPN, right? If you wanted remote access, you controlled that entry point. Things have changed drastically, right? Because business has kind of demanded that we have to work, in cloud services. We're a much more distributed workforce now, in like the post-pandemic world, like Curtis was saying. So microsegmentation can help, for the workloads that are serving your APIs, but it's more so if somebody exploits the application code that serves that API and then kind of pivots their attack, right? So maybe I'm going to try to escape the container that a workload runs in and access some other virtual machine or access an entirely different system, right? So we've actually seen some of these types of attacks with like SolarWinds and the Exchange server attacks where the web channel or the web API was kind of the initial attack vector. And then attackers pivot, right? And you kind of go down the stack, you start accessing the system, and then you access other systems in the network. So microsegmentation definitely helps kind of limit that blast radius, but that's kind of it, right? It's kind of, you've already compromised the app. I want to stop the attacker there. I don't want them to get to other systems. But like I was saying earlier, it's very hard to inform those controls unless you have very good API documentation to inform it, or you're doing very good asset tagging and labeling. As you're creating containers, are they versioned properly? Because that's going to inform your microsegmentation policies.
Okay, so just to finish up on this point then, I mean, from the sounds of it, obviously, it seems like WAFs are almost becoming slightly obsolete in a way. I mean, do you have any thoughts on that and where that's going to go? And are we seeing the end of the WAF?
Is that for me, Michael, again?
Yeah, thanks to you, Michael.
Yeah, I mean, look, from my perspective, they're kind of commodity, right? And the reality is a lot of commercial WAFs are based on mod security. For anybody not familiar, mod security is a very, very common open source WAF engine. You could take it, stand it up on like an Nginx instance. You can create your own mod security rules. It's just for most organizations that's too much implementation and operational complexity. So they'd rather buy from a commercial vendor, get those rule sets like I was describing. So it given the effectiveness of the types of attacks it prevents, it's kind of have it, but if you need to cut budget, you might opt to do just stand up mod security and use those basic rule sets. But you have to look beyond that because this world of business logic attacks is how most companies are kind of getting breached these days.
Okay,
Michael,
great, thanks.
Michael, you mind if I add something there?
Yeah,
sure.
Absolutely.
Both Michaels. So I do agree in that WAF is a commodity. Absolutely, to me it's very much like intrusion prevention was in the day where everybody was scared to implement it, and they finally got comfortable with it. Now everybody puts it in, and they just put it in enforce mode almost immediately. I do think they have some benefits for certain protections, especially like cloud-based WAFs when you're including it with a CDN or something like that, where you can do bot protection and other things like that. With that, with a WAF, it tends to have those. It tends to be effective there, but when it comes to APIs, I think it's something that's just not going to be effective, and you're going to see really what I'm seeing is a roll up into a platform approach where you have multiples of those things in your environment, and it's dare I use an old worn out term of defense in depth that some people don't like, but it's still an effective solution in a lot of ways. If you have multiple things in place to protect against it, I think a WAF can. What you don't want to do is remove something that creates an old attack vector that has been taken away for the most part, and then all of a sudden it becomes effective again. I guess that's the core point I'm trying to make. Yeah,
no, great point. Thanks, Michael. And Curtis, let's come to you now and look to kind of shift this on to another gear maybe. And looking at, obviously we've heard a couple of suggestions here of what can form part of a good strategy for API. But if we're, if you're speaking to an organization that's embarking on a new API strategy and they're looking, from start to finish, how does an organization go about, building that plan? Where do they start, would you say?
I would start with understanding how you want to operationally manage APIs and secure APIs going forward. What is acceptable to you, right? And I think understanding that with any other project as you're facing this is, what do you want this to look like going forward? If you want to manually manage Swagger files, et cetera, and that seems good to you, then your strategy is going to be different than having an ecosystem that self-identifies APIs, that's constantly monitoring APIs. As I look at this, as we talk about zero trust all the time, right? It's a general buzzword, but as I think about zero trust in the world we live in today, to me, the key element of zero trust is the ability to understand normal and to continuously monitor to identify when abnormal has happened to allow for actions to be taken. And as we look at this API landscape that we're facing right now, that's exactly what we're talking about. The problem is that you can't do that at scale. People can't do that at scale. Systems can. So as we think about building APIs, it's less about thinking about point solutions for APIs. It's less about thinking we need to inventory and therefore catalog APIs. It's less about thinking we need to authenticate APIs. It's more about thinking of what does that overall holistic management and security model need to be to support and enable the business in an effective way that's helping us manage risk. And as you think about that, that is an ecosystem. That is a platform. That's a platform that identifies your APIs, that catalogs your APIs, that identifies what normal looks like, that constantly monitors for deviations from normal and allows you to take actions on those deviations, allows you to learn from the exploitation of your APIs such that you can better enrich your development program. This truly is about a closed loop program. This is not about a point solution. And that's the way we've got to think about it, because APIs are here to stay. They're growing at a rate we've never seen before. They will be the main plane at which we interact with systems and systems interact with one another. They will be fundamentally the only plane as we think about how systems and people interact with tooling. And as we think about it from that perspective, where have we invested the majority of what we're doing and how we're doing it without building an effective ecosystem around that, if that's truly where we're going to be making our money going forward? That's how we need to look at this. This is about building a program, not about point solutions.
Good points. Thanks, Curtis. And Michael F., I saw you nodding away there as Curtis was speaking. Anything you want to add on this point and your advice for organizations on how to best go about, carrying out an API security strategy and maintaining it, I guess, as well for the long term?
I absolutely agree with Curtis that it's you have to figure out where you're going to be, what level of maturity do you want to attain. There's a common misconception in all kind of info. Well, I'll show my age. I call it information security still sometimes, but cybersecurity is that the misconception there is that you need to be at level 5 of maturity absolutely in your business, and everybody needs to be, and you don't have to be. You have degrees of maturity, and that can be quite fine for your environment and your company to reach that. So you have to define what that means. And I mean, and if the listeners want to hear some, finer points to things, I mean, I think still it kind of lends itself to what Curtis is saying, is that you still have to do fundamental things in API security like you would do app security or anything else. And those are things like making sure you're practicing secure coding techniques, making sure your developers are able to do that and measure that in some way, and that goes to the platform and the larger program. Making sure that things like secrets management are taken care of, so your API keys aren't just floating out there. I mean, those are things that you need to do in a traditional application security program, and you need to encompass all of that. And as you start focusing on APIs, the documentation portion of that is absolutely key, because if you don't know how your API is documented, how it's talking, what are the endpoints, what do they look like, what calls you're going to make, then it's almost ineffective to start going down that path to start securing them in the first place.
Yeah, great point. Thank you, Michael. And that actually leads us quite nicely into our third poll question. So I'll bring that up on the screen now. So we want to know next, how are you currently inventorying your APIs? Is it A, manual information gathering, B, network infrastructure and or application scanning, C, automatic API discovery, D, other, or E, no process in place? Can I open the voting on that one now? If your option is other, do feel free to pop into the submitted questions section there what the other is. And that'd be interesting to see that for sure. Okay, I'll jot the slides back down there. And then Michael, let's come back to you now on another point, which is something, again, you mentioned earlier, which is obviously cloud, obviously a a big part of our lives at the moment and organizations in general. What's the best way to get a view of the APIs running in a cloud environment, both sanctioned and unsanctioned?
Yeah, good question, Michael. So it's we have to kind of look at the flavors of cloud, right? Infrastructure as a service, in my mind, it's almost traditional at this point, right? It's kind of, you're standing up virtual machines in Amazon's cloud. We've had that for I don't know, 2 decades at this point. It's kind of and it worked very well, right? For kind of that lift and shift data center consolidation strategy, migrate everything to the cloud. And then pay based on consumption. The newer forms of cloud computing, there's levels of abstraction where the cloud provider is kind of taking on more of that infrastructure management. That means you're conceding some things, right? As a security or a governance team, you're going to lose some visibility, right? You lose some control because now you're trusting the cloud provider. And cloud providers, they know this. It's part of those shared responsibility models, and each cloud provider usually has a matrix, so you can kind of say, for this flavor of cloud, what am I responsible for? You're always responsible for the apps and the APIs, right? Like that's the reality. That's why it's kind of unfortunate that they don't really provide you a lot of application security or API security capabilities beyond some of the things we've been talking about, like network security mechanisms or authentication and authorization, or maybe some network segmentation and micro segmentation. So they don't give you a lot of that deeper app layer inspection. So to your question, like how do you get visibility into that API consumption? It needs to be continuous, right? You have to be looking at multiple spots in your network, but then other clouds. Because what tends to happen as organizations build apps is, if something provides value, they're going to integrate that, right? It might not be the API that I've built, but I'm going to call out to maybe a cloud software as a service. Like Google Maps is a pretty well understood cloud-based API, right? Google's providing that. It's a useful service. Maybe I want to incorporate that into my application and its APIs. So I'm going to see that call at some point. Usually I would mediate access with an API gateway, but it's a different traffic flow, right? And we were talking about this earlier, that you do kind of circle back to kind of network communication paths. So, without knowing that up front, you have to kind of tap into your API gateways and API management to maybe see that traffic. The way we try to approach it at Salt is, let's integrate with all of those network-based proxies that you're going to be using anyway as you architect systems and applications. So we're going to see it, right? And we're going to continuously inventory or build that inventory for you, because it's really hard to document everything up front, and inevitably an app team is going to call out to something that might be unsanctioned, right? So if you're tapping all those network points and services in your environments, known environments, you're likely going to see a call out to an unsanctioned environment.
Great. Okay. Thanks, Michael. Great points made there. And had an interesting question come in here, which we'll take a look at, and very much speaks to what we were talking about earlier in regards to how APIs can be targeted and attacked. One of our viewers has asked, my boss thinks attacking APIs is pretty hard, so not very likely. Is that point of view correct? Curtis, any thoughts on that?
What attacks are still hard to execute, I guess, would be my general question, right? We used to say supply chain attacks could only be executed by nation states. I think we've long since disproved that. If you look at, quite honestly, we talked about Shodan earlier, we talked about the likes of Metasploit. Everything is relatively easy now. And we also were talking earlier today about some of these man-in-the-middle proxies that expose all sorts of interesting information about APIs. Let's just talk about that for a moment. Those man-in-the-middle proxies, a number of them were named. I've been using another one called MITM proxy for a long time. There are a laundry list of these solutions that allow you to rapidly understand APIs, what's available through them, how they're used, how you can exploit them. I'm talking within minutes. I've seen YouTube videos more recently of kids doing this, like literally 16 or younger, who are trying to build an app but cannot use the API that they want to use because it's a private API. Therefore, they deploy man-in-the-middle proxy. They use their mobile device and their computer. They gain all the details they need to understand how to use that API, including the access key associated with the API, reuse the access key, consume it in whatever way they want to, need to. And in that specific example, that's not malicious. The same general practices can be applied in a malicious capacity without a lot of difficulty. This is very straightforward to execute today. And again, we've got kids doing it. We've got bad actors doing it. Everyone's doing it for different reasons, but it's not hard.
Yeah, great points. Thanks, Curtis. And Michael, let's come to you on this point around awareness, and just to get some general thoughts on where you see, generally organizations, how high on their priority API security is, and how well companies are actually doing with it at the moment. Do you have any thoughts on that?
I'll start backwards. Generally, how well they're doing is not good. The problem I'm seeing from a business standpoint, a prioritization standpoint, is that application security, and we've all probably complained about this for several years since we all have experience here. API security tends to get a lot less focus in the entire cybersecurity market. So you've already got cybersecurity, everybody complaining that it's a smaller portion of the entire budget than it should be. API or app security itself is a smaller portion of that larger bucket. And then API security is an even smaller portion of the AppSec budget. So what we're running into is that, and what we typically tell a lot of our vendors, that if you're not a line item in the budget, it's going to be very hard to get visibility in with the business, because it's not something that's already there. So you're having to argue for another line. Well, application security is generally a line in the budget, but you're having to pull out of that group of funds to get API security in place. So so you're having to have a whole nother argument that's even more difficult to have, because you're trying to pull from budget that's probably already allocated to what we talked about before, traditional technologies like WAF or SAST or DAST or whatever. You're having to add that on. So I would say the visibility is increasing several fold every time. I've had several conversations in the last month alone with customers about API security. So the awareness is there. They're realizing that the APIs are more prevalent and becoming, as Michael I said earlier, more of the part of just the infrastructure, and they're not going away. So they're starting to realize that now. And the DevOps teams I'm actually seeing a lot of focus from the other side, the development side of the aisle, which is fantastic, that APIs need to be secured. And so that word of AppSec in general has gotten to them. And then APIs, as they develop more and more and more of them, they're starting to sound the alarm. So it's actually kind of refreshing.
Great points. Thanks, Michael. And Curtis, let's just come to you for a moment. I mean, what's your advice on organizations and how they should go about, putting budget towards API security, and how they can go about paying for it?
Yeah, like with anything in obtaining security budget, you've got to relate it to business strategy, business priorities, business focus areas, et cetera. So a couple of things that I always recommend to folks. First and foremost, we talked about digital transformations. If you don't know what the digital transformation is intended to do at its finest points across different functions, understand that quickly. And then relate that back to APIs are supporting those business capabilities of the future. And your lack of visibility into those APIs means that you no longer are able to provide assurances around the risk that you're able to manage, and the fact that you can maintain uptime of these solutions and help recover if they're impacted. That's the general conversation, knowing that we're running out of time here, but you've got to relate the risk back to the business's focus areas and the things that they know are going to be making them dollars going forward, and or saving massive dollars to enable the business they need in the future. Being able to correlate the fact that APIs are enabling that and the risk that they pose and the need that you have to truly enable those capabilities now into the future is the way to actually push this forward, get that budget, and to progress with that implementation.
Yeah, great advice. Thanks, Curtis. And Michael, let's come to you on the result of the poll question that was just relating to general awareness and where API security sits within organizations' priority lists. So we obviously asked, where does API rate on your company's priority list? Top answer, 33% have opted for medium priority. We're just starting our research. That was followed by 28% who opted for high priority. We're researching solutions now. And then the next top answer was 23% unsure. So with just 9% saying not even on our list, I'm interested in this topic, and 4% low priority, we're just becoming aware of the need. So we've got 33% there at least saying medium, or plus another 28. So you've got the best part of 60% there. It's either medium or high. Are you surprised by that, or is that what you thought you would have seen? And is that where is that?
Maybe a little surprising. I would, usually what I see is it doesn't, to Michael's point earlier about budgets, right? Kind of how that gets carved out. Cybersecurity is definitely kind of top of mind. Then it kind of AppSec falls lower in the pecking order, and then API security, if it even makes it, it's going to be a very small amount. What I would probably say is, like, what is the perception of what API security means to you? Right? Maybe it's an identity and access management focus. Maybe it's TLS everywhere, right? Those were kind of techniques that was kind of the approach to API security for a long time. Like if I was using, encrypted transport, HTTPS, I was protected. And if I was behind my identity and access management, or SSO, I was protected. I used to run into this all the time as a practitioner. I think that was one of the other questions, like, attacking APIs is hard, so should we worry about this? Usually the way I cut through that, and it took all of 5 minutes, like what Curtis was saying, I'd fire up an intercepting proxy. I'd show them, look, this is how you man in the middle an encrypted connection. Like, I am doing that to myself. I can see that traffic. Now I know everything about how your API works. But that was always a stumbling block. It was almost like a mental block for application teams building things, right? Because they're very focused on, I need to make this thing work. I am told by security that, if I protect data in transit and I enforce authentication and authorization, I'm good, right? Those are the marching orders. It wasn't wrong, right? There's very good security controls, but it's only one piece of the puzzle, right? And attackers know that is just one small piece of the puzzle, and they can kind of, bypass that very easily. So my first take on that is that it might be different perceptions of API security. I really hope everybody is kind of taking a deeper look at this and thinking about it beyond kind of traditional security approaches, and even some things like, in DevOps, where we're pushing a lot of security testing and build pipelines. Because we've talked a lot about, like, API attacks. You can't see these things pre-deployment. You have to be kind of watching API consumption and runtime. So yeah, I would love to ask follow-up questions, but unfortunately the polls aren't structured that way. But yeah, I guess a little surprising for mine.
Yeah, certainly interesting. Okay, let's have a quick look at the first poll question that we asked as well then. So we asked, does your organization use an API gateway? Top answer, 65% yes. Nobody said no, but we're working on one. Only 15% said no, 20% unsure. But more interested to get to poll question number 3, which gives a little bit more detail. So we asked, how are you currently inventorying your API? So some mixed results here. So top answer, 33%, was network infrastructure and or application scanning. That was followed by 27% who said unsure, 22% going for manual information gathering, 16% saying other. So what do you think, Curtis? 33% saying network infrastructure and or app scanning. Do you think that's how most organizations are currently inventorying their APIs?
Absolutely. So there's been, as was talked about, right, as app security was it wasn't abandoned, but it wasn't necessarily being invested in for a number of years. And then in the last few years, we've seen people really double down on their investments in app security, both in terms of resources and technology. And as we've talked about, there's been some engineering around those capabilities as folks have really gotten closer to the DevOps functions. What they've really focused on together, if they're maturing those pipelines, is engineering around an application security testing capability. So with so much time, money, and effort spent on those solutions, it's no surprise, and this is where we commonly see this, but this is where it goes back to what we've been talking about. Those solutions are giving you general insights into where you have known flaws with code. What they're not telling us is that we have logic-based issues with the APIs that we're building. So I'm not surprised to see the answer just because of, again, the investments we've made there. But to just re-underline that point, it doesn't help, right? The assistance that those AST capabilities are providing in terms of APIs is so limited. And then the challenge becomes, especially as we start looking at data privacy obligations and things like that, how comfortable are we that that limited awareness is actually solving the problems that we've set aside for ourselves to solve, right? Because in general, it's not. We're not understanding how we're putting ourselves at risk in terms of GDPR and CCPA. We're not understanding how we're potentially exposing proprietary information through those APIs. We're not understanding how the logic can be exploited to pull not just my record, but thousands of records from the database. We don't gain that understanding from an AST capability. This is where what we've said today is truly requiring a new thought process, a new approach to be able to understand and manage that risk in support of the outcomes the business is trying to enable.
Great stuff. Thanks, Curtis. And Michael F., let's come to you here. Just we look to wrap things up with a few minutes left. What's your predictions in terms of what you think we'll see from API security in the next 12 months? And if that's any different to actually what you hope you'll see as well?
Oh, that's a hard question. That's very open-ended. So my predictions are that there's going to be some platforming. As I mentioned before, you're going to start seeing more of the API security functions being built into single companies versus there being a lot of point solutions. So I think the ability to do testing, to do inventory, to do any kind of API security that you can think of, and that's the baselining, all of that is going to start getting rolled up into some more mature type of companies. I think the testing to me is a big part of it because in the past, in my past life of doing application security, it's always been, in order to find business logic flaws, it's always been a very manual function and very difficult to find as far as a tester goes in a lot of ways. I'd say difficult as much as time consuming and could take weeks to get a lot of good stuff done in an API. Whereas now, if we're starting to see this onset of more proactive type of approach to API testing and API inventorying, I think that as that gets fleshed out and as we get better math and for the models that get built for being able to say whether something is a problem or not, based on just baselining, based on threat intel, active attacks, as those start getting added to it as well. When you've got threat intel of something that's being exploited in the wild, then you'll be able to prioritize based on those as well. Those are how things I think are coming down the pipe. I'm hoping they are, and making it more secure. So.
Fantastic, thanks, Mike. When Michael, I just come to you on that same point. Then, what do you think the next year or so has in store for API security?
Lots more attacks and incidents and breaches, and it's funny too. Like a lot of them aren't super sophisticated. You know, we've seen some really high-profile incidents and breaches that were, you know, they sometimes get dismissed as like poor coding practices or like rookie coding errors, but it kind of ignores the problem, which is, you know, application design it's very complex, and actually a lot of application development, it's multi-team, right? You might only own a piece of code. You don't own the system end to end. So when that fully integrated system is in production, it's anybody's guess what's going to happen, right? So a lot of incidents and breaches they're kind of basic things like, you know, the authentication either wasn't there or it just wasn't configured correctly. But then even beyond that, you know, we see things like the business logic attacks where, you know, attacker is just going to find a crafty way to consume your APIs and data that you just didn't intend for. And how do you block that, right? It's not an issue in code. You know, you're likely enforcing authentication and authorization. So you have to be a little bit more creative of how you do these things in runtime. And it really shifts that focus out of, you know, kind of that shift left, doing everything in build pipeline. Yes, we have to do those things, but you have to consider kind of this bigger picture. That's kind of why, you know, at Salt we've architected the platform to kind of be full life cycle, right? Because it's very important to look at these things and design development and build time, but also in runtime, right? That gives you the complete picture. So yeah, my predictions are, the attacks are going to trend upward. We've seen those predictions. We see it in the Verizon data breach investigation report. I try to cover them in the SALT blog as they happen, but they're very frequent, right? It's like some days you can't even keep up. It's a daily occurrence. So yeah, that's my predictions.
Fantastic, great stuff. Thanks, Michael. I think that's a great note to look at to wrap things up with then. So yeah, huge thank you to all three of you, so to both Michaels and to Curtis as well for joining us. Fantastic to have you here with us and really enjoyed hearing your thoughts. Big thank you to Security as well for their sponsorship of this session. Great to work alongside you to put this together. Big thank you to our audience for joining us. Hope you enjoyed the webinar. Don't forget that if you want to watch it back, you can do on demand on our website very shortly. So if you were slightly late to the session, or if you just want to watch it again, it will be available for you to watch back very shortly. With regards to what's coming from us next, our next webinar is taking place next Thursday, the 8th. And that one is Pharma Drama, Interactive Crisis Simulation of an Insider Threat. So we look forward to you joining us for that one if you can. Without further ado, we'll say one last thank you to you all for joining us, and we will end the session there. So thank you very much all.
Great. Thank you, everybody.
Appreciate it.